Topic number 3 is solving a rational inequality. In this video, I will go over example number 1. Solving the following inequality, we have a fraction on the left side, and the other side we want to see 0. But it's not 0 yet, right? The other side is number 2. So we need to do something. Always have 0 on the other side of the inequality, okay? So we're going to have to first subtract 2 from both sides, okay? So take a look. I will subtract 2 from this fraction, x plus 6 over x plus 1 minus 2 is less than 0, right? I can subtract 2 from both sides so that the right side, if you do 2 minus 2, will give you 0, and the minus 2 will appear on the left side. Now, to subtract fractions, we need them to have common denominators. So what I will do is this. Let me move this a little bit to the side. On top and bottom of 2, I will multiply this fraction, this by x plus 1 over x plus 1. Because x plus 1 over x plus 1 is just 1, multiplying anything by 1 does not change its value. It just looks different. But this is perfect now because if you take a look, both of the denominator is x plus 1. I can now combine these or add the numerators. So if you pay attention to the numerator, that is what I have. So I'll go ahead and write that down in a single line, okay? That is x plus 6 minus 2, parenthesis x plus 1. And the denominator is simply x plus 1, and that is less than 0. We will go ahead and simplify the numerator now. Okay, distribute the negative 2. You will get x plus 6 minus 2x minus 2 all over x plus 1 is less than 0. Okay, let's combine some like terms. I see a positive x and negative 2x. So if I combine them, I will get negative x. Oh. Circles terms will combine to negative 1x. And if you look at the constants, we have plus 6 and negative 2. They will add up to plus 4. All over x plus 1. And now we are ready to solve this rational inequality. So you will have to use, your algebra skill to subtract or move a constant to the other side so that you have a rational expression is less than or greater than or less than or equal to or greater than or equal to 0. The goal is to have 0 on one side first, okay? Once you have that, we're ready to start. So let's go ahead and start this problem, okay? So over here, I'm starting my new work. So far we have it in the form of negative x plus 4 over x plus 1 is less than 0. To solve this rational inequality, what you will need to do is find the zeros, okay? Find the zeros of the numerator and of the denominator, okay? So let me go ahead and write that down for you, okay? Find 0 of numerator and find 0 of denominator. First, let's look at the numerator function. The numerator is negative x plus 4. So you will write that down, negative x plus 4, and you will set this equal to 0. And let's solve this. If I add x to both sides, I'll get 4 equals x. So the first 0 is x equals 4. Okay? If I solve the denominator is x plus 1, right? So you will say x plus 1 equals 0. Whoopsies. You will say x plus 1 equals 0, and you subtract 1 from both sides, you will get x equals negative 1. So these two zeros from the numerator and the denominators are your boundary points. So on a number line, we are going to plot them. Go ahead and plot these over here. Smaller number is negative 1. Bigger number is positive 4. Okay, now let's talk about the type of circle. The denominator, no matter what, the zero of the denominator has to be always open circle because the bottom of the fraction cannot be equal to 0. That's why the zero of the denominator, you must always plot an open circle. Always on open circle for 0 of denominator. But that's not always true for numerator, because numerator can be equal to 0 if they are looking for less than or equal to or greater than or equal to 0. Let's take a look at the inequality symbol one more time. Oh, look at the inequality symbol. The inequality is simply less than 0, right? That's simply less than 0. So we're gonna have to use the open circle again. So sorry, just gonna be both open circle. But as you can see, later we will look at examples where one circle is open, the other circle is closed, and that may happen for rational inequalities, okay? So what we now do is just the same thing. We're gonna plug in some checkpoints, some values, and then we're going to plug them in to see if this comes out to be true. So let me go ahead and pick a number that is to the left of negative 1. I will plug in x equals negative 2. Okay, if I plug in negative 2 for this interval, because negative 2 is smaller than negative 1, let's see what happens. I'm plugging it into that inequality, okay? I will get negative 2 plus 4 over negative 2 plus 1. We want to see if that is less than 0. Let's see if that's true. The numerator will be positive 4 plus 4. The denominator is negative 1. And if I simplify this, I get 8 divided by negative 1, which is negative 8 is less than 0. And this is true. Because this number came out to be true, what we know is everything to the left of negative 1 will satisfy this inequality. So we found one answer interval. Let's find more, okay? Let's check out the one in the middle. Let's plug in a number that is in between negative 1 and positive 4. I will plug in x equals 0, okay? If I plug in x equals 0 into that inequality, I will get negative 0 plus 4 over 0 plus 1. I want to see if that comes out to be less than 0. So focus on the purple piece, okay? The numerator is 4. The denominator is 1. 4 divided by 1 is 4. And this is a false statement. Because this is a false statement, I'm not going to highlight or underline that section in the middle because that is not the answer interval. I only have one more interval to check. All right? Let me go ahead and just make this a little bit smaller so that I have more room. How about a number that is to the right side of 4? What number may I plug in? I can plug in. I will not use purple pen again because they're going to be right next to each other and it's going to look confusing. How about I go with orange pen? All right, I will plug in a number that is to the right side of 4. X equals 5 works, right? I'll plug in 5 into the inequality. Let me zoom out to see the inequality. I am plugging 5 in here, okay? I'm plugging 5 in here. So that will be negative 5 plus 4 over 5 plus 1. I want to see if that is less than 0. Whoopsie, I'm outside. All right, hold on. Let me move my iPad a little bit so that you guys can see everything. And I'll zoom in over here. The numerator is negative 1. The denominator is 6. Okay, is negative number smaller than 0? Oh, that is absolutely true, isn't it? because this inequality came out to be true, what I know is that this interval to the right side of 4 is also the answer interval. So we found it. We solved this inequality. Let's go ahead and write the solution then, okay? Guys, I may need more room here. I think I will go ahead and just move this problem to another page. I'll copy this. And I wonder if I can just write over it. Give me 1 second. Let me stop this video for a second. I erased number 2 out of this page. So here's the solution now. Whoopsie. The solution for this inequality is the 2 intervals that are underlined. So the first one, the one that's going to the left, which is negative infinity, but stopping at negative 1. That interval is going to be negative infinity to negative 1. I close the parenthesis because it's an open circle. Union, what's next? Starts back at open circle of 4 and going all the way to the right. So I will do positive infinity. So that is how you can solve this type of rational inequality. I have a couple more to show you, so come back and watch all 4 videos on topic number 3, okay?